Hello everyone. Today we are going to discuss about an interesting uh, algorithm that is related to the social network, or you can say web mining, related uh, topic, which is Girvan-Newman algorithm. So Girvan-Newman algorithm is basically used for community detection. Okay, so this is one of the most popular algorithms that is being discussed when the community detection and such kind of topic is being discussed. That time this algorithm obviously will come. So this is a very popular algorithm. Okay, and so what is mean what is this Girvan-Newman algorithm? It is designed for finding communities using divisive hierarchical clustering. So you know that community detection or finding community is an important task, okay? because in social network, finding community has got lot of importance, okay? Because entities inside one single community or the nodes behave in a similar way. So that has lot of significance from graph theory point of view to analyze the network, because you know that social network is day by day it is growing, and it is part of our life. So a lot of things are related to the social network. So Girvan-Newman algorithm is designed for finding communities using divisive clustering technique. But here the underlying assumption is that if a network has a set of communities and these communities are connected to another with a few edges, then all shortest paths between the member of different communities should pass through these edges. So basically here the edges between two nodes and its significance has been discussed. That means if the shortest path between any two nodes inside the graph passing through a particular edge, then that edge will be having a lot of significance, and based on that this Girvan-Newman algorithm is being established. So basically what happens is that by removing these edges, which are called weak edges, we can cover communities in a network. We can recover community. That means we can discover the community in a network. Okay, but how to do that? That minimum I mean the shortest path that is passing through that particular edge, that particular concept is called edge betweenness. You can see here I have highlighted with red color. This is edge betweenness. We have to find the edge betweenness. Okay students, so edge betweenness you have to find and remove edges with higher edge. That means every time we will find the edge betweenness of a particular edge, not particular, actually we will be finding all the edge betweenness, and whichever has the maximum edge betweenness we have to delete that. Meaning is that if we delete those edges, then it will be calling the weak ties are getting deleted, and so that you can recover the community. Okay, but to understand the edge betweenness, before that numerical expression or the the actual mathematical expression of edge betweenness, before discussing that, what is edge betweenness, let us understand in more detail. So for an edge E, edge betweenness is defined as the number of shortest path between node pairs such as Vi, Vj, such that the shortest path between Vi and Vj passes through E. That means you have to understand this concept. It is telling that it is saying that edge E, that means the edge that is under consideration, the edge that we are going to find, the edge betweenness of that particular edge. Okay, that edge that age, whichever age, it has to be all the ages. Actually, you have to find the age betweenness for all the ages. Let's say this is my age, A and B, A, B, C, D, E. This is my graph, and this is the age that I'm interested with. Okay, let me change the color, make it black. Okay, so this age I'm going to find the age betweenness first. That means AB, means the age that is under consideration is AB. I have to find the age betweenness of AB. So similarly, you have to find the age betweenness of BC. You have to find the age betweenness of CD, like that. Okay. And so how to find this? What it says, let us go back to the definition first. It says that number of shortest path between the node pairs VI and VJ such that shortest path between VI and VJ passes through. Actually, the formula of age betweenness is age of E is nothing but, have to find, you have to understand this concept, is that how many shortest path actually have passes through passes through this edge AB. Okay, that is the first thing. And let's say the meaning, what I try to say is that, let's say I'm going to have the shortest path between B and E. Okay, so B and E shortest path, if you see, it is 1 1 2. Okay, B and E shortest path is 1 2. Let's say there is another edge here, so 1 2, this is one shortest path, and this is another shortest path, 1 2. That means BAE and BDE, these two shortest paths are existing here. Okay, so what we will do, so either you can come through this to this, if I am considering BE. If I am considering BE in this direction, BAE, that is also shortest path, but BAE is actually having this age AB, that is the age that we are actually the age that is under consideration. Okay, so this age is, this BAE is the shortest path which holds AB, although BDE is another shortest path. Okay, which is not holding, it is not having this age, not including this age AB. So the age betweenness will be, first thing is that number of shortest path to AB and number of shortest path. Okay, so numerator is the number of shortest path that is having AB, and denominator is number of shortest paths, okay, not having and having both. So, and then this is for one pair of vertices. You have to consider all pair of vertices if you want to consider the age betweenness of B. So you can have a summation here. Okay, you can have a summation here. So for all pair of vertices. So here is nothing but, because this is the first path of length 2, which is having AB in its path, and another one is ADE. Both the cases the shortest path size is 2. So here it will be 1, and 1 means number of shortest path through AB is 1, and another one is the number of shortest paths which is including as well as not including, is there will be total number of shortest path, total number of shortest path. Okay, which is 2. 1 by 2 is the age betweenness of, so like that you have to find for all the vertices. So this is just for you can write it, this is nothing but this one is for for the start here, B, I'm writing here BE, pair of vertices B. So pair of vertices BD, you can see that BD you can directly reach from B to D. So no need of, there is no way that I can include AB and then I can come from B to D. There is no way I can do that. So it will be 0. Okay, it will be 0. So BD it is 0. BC also same, it is 0. Like that things will go. So this is how you should consider. So you have to consider all the pair of vertices. All the pair of vertices you have to consider this. And whichever is the summation marks, that will be the summation value, that will be the edge between them. Now let us come to the, so how you should, how this algorithm works. First thing, calculate edge betweenness for all edges in the graph. Remove edges with the highest betweenness. That means whichever edges is having, whichever edge is having highest betweenness, that has to be deleted. After deletion of that edge, graph will be a new graph. You will be having a new modified graph. From that modified graph, you have to again find the edge betweenness, and you have to keep doing it until unless you get individual component or individual communities. Okay, so you can see here that we are going to find the edge betweenness between, so here let us say our initial E is nothing but 2 1 or 1 2, you can call it. This edge betweenness we are going to find this one. So for that, let's say for vertex 4, how can you reach vertex 4? So all the vertex you have to consider. Okay, all the vertex you have to consider. So vertex 4, you can either visit to this and this one way, or you can do this and this. That means 2 way. That means 1 by 2 for vertex 4. Okay, for vertex 6, same 1 2 3 one way, or you can visit 1 2 3. So this 1 2 3, it is actually having this 1 2. That means the edge under consideration, edge betweenness. So that means 2 way you can visit from 2 to 6. One is this, another one is this. So it is also 1 by 2, because numerator is the number of shortest path that visits through the edge, 2 1, so that is 1 only, and total number of paths exist are 2. Similarly for this is for 6, let's say. Similarly for 7 also same 7, or 8 also same, 7 8 5 also same, 6 also same, 6 to done, 9 also same. So 1 2 3 4 5 6, this is 2, not 5, 2, also 2. Okay, so these all are done. What about vertex 3? Vertex 3 is 0. Okay, or vertex 3 is 0, because directly you can visit 2 to 3, which must not include this, because if you include this and this, then it will be 2. So 2 to 3 directly you can visit, so it is 0. And what about the vertex itself and the edge itself? That means 1 to the edge under consideration, which is edge betweenness that we are finding, which is E12. This is only one way you can go, so that means 1. So that means for vertex 4, vertex 1, vertices, pair of vertices 1 and 2, that means edge 1 2, you can actually, the edge betweenness of, I can write it here, edge betweenness of 1 2 is nothing but this, which is coming across 3 plus 1 4. So you can see that 1 and 2, the edge betweenness is 4. Okay, now let's say 2 and 4, 2 and 4, this one directly there is no connection, so edge betweenness will be 0 initially. Okay, wherever there is a direct connection, edge between, we have to find that edge betweenness only. So 2 to 4 is 0, 2 to 5 also 0, because there is no direct connection, so all these things are 0 0 0. We need a single edge. Okay, single edge. Similarly, you can calculate for 3 1 3 2, like that. 3 1 also you can calculate edge betweenness of this, 3 2 edge betweenness of the, all edge betweenness you have to calculate. So there are 1 2 3 4 5 6 7 8 9 vertices are there, so you should have 9 vertices this side, 9 vertices that side, whichever is the direct connections are there, you have to find the edge between s. After having this edge between s, you have to find which edge between s is actually maximum. So if you see here, is 4 for 1 and 2, it is 4. Just now we calculated the first edge that needs to be removable. So now after having this matrix filled, which edge to be removable? According to the algorithm, you see, remove the edge with the highest betweenness. That means the edge which is having the highest betweenness. So you can see the highest betweenness is having this 4 and 5, 4 5 or 5 4, whatever you call it. These two entries are having the highest value. Also 4 6. So there is no specific rule which one you should pick up. You can pick anything. So let's say 4 and 5 you are deleting. So you have to delete the 4 5. So by removing 4 5, you have to compute the edge betweenness again. And you can see that once you calculate that, that means initially let's say 4 5 you are deleting. Okay, 4 5. Yeah, 4 and 5. So 4 and 5 means this edge will be deleted. Okay, so the resulting will be like 2 3 1 4 5 8 9. This is there, this is this. So your daily, this one has gone 5 8 6 5 8 6 7 6. This edge will remain, and this all will be remain. All will remain. This is also there. This also there. Okay. So this is the situation. But we have deleted this edge. This edge, this dotted edge has been deleted from it. Now it is a new graph. From this new graph, again you have to calculate the edge betweenness. Okay. Again you have to calculate the edge betweenness, and then if you calculate that, you will find that the next iteration 4 6 has the highest edge betweenness, which is 20, which will be 20. You calculate it, you will find it. Okay, so and remaining edges are edge betweenness are like this in the second iteration. That means 20 has to be deleted. So here 20 is 4 6. That means this fellow has been, this edge has to be deleted. If you delete this edge, then it will be 2 3 1 4. That means this all connected. Okay, this is connected, this is connected, this is also connected, and this, if this gone, means 6 7 9 5 8 9. This will be the scenario. Correct. This is the situation here. So now again you have to calculate the edge betweenness. Okay, finally if you calculate again the highest edge betweenness after the deletion of 4 6, you will find such kind of community with you. Okay, so you see here 9 will be deleted. That means in the next iteration this edge will be having the maximum edge betweenness. Okay, this edge will be having maximum edge betweenness, and finally you will be having these 3 communities. This is community 1, this is community 2, community 3, using Girvan-Newman algorithm. Okay, is used for community finding. I hope you understood this concept, and thank you.